Next problem, find the current supplied by the battery of the network. Okay, so which means find the current supplied by the battery of the network. So here there's only one battery and there is this 4-volt battery over here, and so they said find the current supplied, right? So suppose that means if I mark this, so there here in the circuit there are totally 3 meshes, right? 1, 2 and 3. So mark each of these meshes with their mesh current. So let this be I1, let this be I2, let this be I3. Okay, so this is I1, this mesh over here is I2, and this mesh over here is I3. Okay, so they said find the current supplied by the battery of the network, which means find the value of I1, because I1 is the current that is flowing from this battery, right? So find the value of I1. So let's do this question. So first I'll write the equation for mesh 1. So no matter how the shape of the circuit will be, the procedure will always be the same. Okay, that's all. So equation for mesh 1. And here the mesh 1, here like I said, on that corresponding current will be positive and the remaining current will be negative. So here this is mesh 1, right? So therefore I1 will be considered positive and I2 and I3 will be considered as negative. So here I1 touches 3, 1 and 4 ohm resistors. So 3 plus 1 4, 4 plus 4 8. So you have 8 I1. Okay, and I2 touches only this one, so it will become minus I2. And I3 only in this mesh 1, I3 touches mesh 1 only through this resistor, right? So it will be minus 4 I3 is equal to, and here the voltage source is only one voltage source, and this voltage source, this supplies the current I1. It supports the current, right? It supports the current I1 because it is flowing from the positive terminal. So it is 4 is equal to 4. So this is the equation for mesh 1. The equation for mesh 2. Equation for mesh 2. Okay, so here in this mesh 2, current I1 is flowing over here, right? So it will become minus I1. Okay, and this is mesh 2, so therefore I2 is considered positive, and I2 touches 1 ohm, 2 ohm and 5 ohm. So 1 plus 2 3, 3 plus 5 8. So it will become plus 8 I2, and I3 touches only this 5 ohm resistor. It will become minus 5 I3 is equal to 0, right? This is the equation for mesh 2. Now for equation for mesh 3. Okay, mesh 3, it will be minus 4I1, right? And in this mesh there is minus 5I2 over here, so it is minus 5I2. And I3 is positive, and I3 touches 4 plus 5 9, 9 plus 6 15. So 15 I3 is equal to, there is no voltage source, so it is 0, right? So now writing the equation in the matrix form. We get, so the coefficient matrices here is 8 minus 1 minus 4, 8 minus 1 minus 4, minus 1 8 minus 5, minus 1 8 minus 5, here minus 4 minus 5 15, minus 4 minus 5 15, and the unknown variables are I1, I2 and I3 is equal to, and the voltage source matrix are 4 0 0, 4 0 0 there. Okay, so this is the matrix equation. Now I will find the value of I1, I2 and I3. Okay, so the value of I1 is, it's the ratio of the determinant of the first matrix, in which the first column will be replaced by 4 0 0. So here it will be a 4 0 0, and the remaining matrix will be same, minus A1 minus 1 8 minus 5, minus 1 8 minus 5 minus 4 minus 5 15, minus 4 minus 5 15, divide by the determinant of the coefficient matrix. 8 minus 1 minus 4 minus 1 minus 4 minus 1 8 minus 5 minus 4 minus 5 15, right? So this is equal to, let's do this question. So it will be 4 into, here 8 into 15 is how much? 0 4 120, right? So 120, and this is minus 25. So 4 into 120 minus 25 plus 1 into plus 1 into, this is 0 plus 1 into 0 and minus 4 into 0. This is the numerator, okay, and the denominator is 8 into again it is 120 minus 25 plus 1 into, let's see, minus 15 and 20, so minus 20 and for the last one it is minus 4 into 5. Here it will become 5 minus 32 becomes plus 32, right? So therefore I1 is, so here it will become, here is 4 into 120 minus 25 is 100 minus 5 95, so it is 4 into 95 by, and here it will become 8 into 95, and this is minus 35 and this is minus 4 into 37, right? First I need to find the denominator separately so that I could use that to find I2 and I3 also. So numerator is 4 into 95 and we have 380, so which means this is 380 by, and the denominator we have, let me see, 8 into 95 minus 35 minus 4 into 37, and we have 577. So the denominator is 577. The reason why I'm finding the denominator separately is because I can use that to find I2 and I3, right? That's why. So now 380 by 577. It is 0.659. 0.659 amperes. This is the value of I1, right? Now next is to find the value of I2. So now to find the value of I2 is equal to, and the determinant is replacing the second column with 400, replacing the second column with voltage source. First column will be the same, second column will be 400, and the third column will be the same, and the denominator will be the same. 8 minus 1 minus 4 minus 1 8 minus 5, here it is minus 4 minus 5 15, right? So here we have, let's see, 8 into 0 nothing, minus 4 into, we have minus 15 and minus 20, right? Minus 4 into 0, that is the numerator, and the denominator is the same, that is 577. See, this is why I found the denominator separately, so that I don't have to find it again, right? So try to save time as much as possible for these kind of questions. So we have minus 4 in the numerator, right? We have minus 4 into 35, minus 35, minus 4 into minus 35 divide by 577, and the answer is 0.243 amperes. So therefore I2 is equal to 0.243 amperes. Okay, 0.243 amperes. So this is the equation value of I2. Next we'll find the value of I3. So I3 is equal to, and the first column will be the same, 8 minus 1 minus 4. Second column will be the same, minus 1, 8 minus 5, and the third column is replaced with the voltage source, 400, divided by, and the coefficient matrix will also be the same, 8 minus 1 minus 4 minus 1, 8 minus 5 minus 4 minus 5, 15. Okay, is equal to, so we have over here 8 into 0, okay, plus 1 into 0 plus 4 into, we have over here as 5 minus 32 becomes plus 32. That's it, and divide by, and the denominator will be the same, 577. So which means we have over here 4 into 37, 4 into 37 by 577, which is equal to, we have 4 into 37 divided by 577, which is 0.256 amperes. 0.256 amperes. That is the value of I3. So I found the value of I1 and I2 and I3, but the question is, find the current supplied by the battery of the network. So the current supplied is I1. Therefore, that is the equation. Therefore, current supplied by the battery is equal to I1 is equal to 0.659 amperes. Okay, so this is the answer, right?